I have the pleasure of being your next speaker today. So I'm Ian Smith from the GSMA. Let me put my props on the table. So it's a pleasure to be here today, or thank you, to talk about some of the work the GSMA has been doing. I think the last speaker covered a lot of the territory already, so it's made my life a lot easier. First thing I probably need to do is just introduce the GSMA. You may not be familiar with us as an organization. So we're a trade body, not-for-profit trade body. So we're member funded, and our members mostly come from the cellular network operator community or carrier community. So obviously in this region, this is the likes of AT&T, Verizon, T-Mobile, and so on. Now, obviously, our members, they pay their subscriptions each year. We provide them some very valuable services in return. The reason the organization was founded well over 25 years ago now was to enable roaming between network operators. And obviously, we still do a lot of work in that area to make sure that there's a seamless roaming experience wherever you go in the world. But the reach of the organization has very much broadened out since then, and we now have a whole raft of activities inside the GSMA that are focused on enabling new market opportunities for our members. And the Internet of Things is obviously a huge opportunity for most of our members, primarily perhaps in terms of connectivity services, but also in terms of value-added services, and that's what I'll go through today. So I'm going to touch on the connectivity aspects, look a little bit at the security, and then look at some specific security services that we've just recently developed inside our organization. So firstly, let's talk about mobile IoT. Mobile IoT is what our marketing folk at GSMA, I would have called it cellular IoT, but they call it mobile IoT. So it's about using cellular technology to connect IoT devices. Now, you can pick a figure out the air. This is what our internal analyst house comes up with in terms of the number of connected devices, IoT devices, over the next few years. One important thing to note here is that we don't think cellular is necessarily going to rule all of the world in terms of the 25 billion connected devices. It's going to be very much a subset. We look at by 2025 there being sort of 3.5 billion connected IoT devices over the cellular technologies. And you can see some of the vertical sectors that we're targeting, the kind of main sectors that are driving those cellular connected devices, smart cities, connected vehicles, consumer electronics, smart home, and so forth. These numbers aren't necessarily going to be based on the types of network, the 3G, 4G, 5G networks that we perhaps have today. What we're seeing our members deploy around the globe are low-power wide area network technologies, specifically technologies based around LTE-M, Cat-M, and narrowband IoT. So those are the two technologies that we see under that headline of mobile IoT. Obviously, these technologies are providing different capabilities from the 4G networks that we're familiar with today. They specifically target low-power applications, low-cost devices where we have perhaps battery life. We have to have extended battery life, perhaps periods of many years. Obviously, there's some compromises here to have, networks that penetrate in building, that offer this kind of lower cost of entry, lower cost of connectivity. There are some trade-offs in terms of perhaps, the raw data rates that these networks can provide. But nevertheless, many IoT applications and services out there don't necessarily rely on, huge amounts of bandwidth. It's the connectivity, it's that raw connectivity that's really required to drive the adoption of those particular services. And these are what these two network technologies are specifically designed to address. Now, I can't see you too well with all these bright lights on the stage here, but I do have a question for you, and that's to ask whether you've actually experienced or used LTE, Cat-M, or narrowband IoT. I wonder if you perhaps give a show of hands and tell me if you've actually experimented with any of these technologies, these connectivity technologies in the room here. So a few hands have gone up. Well, It's good to see a few hands up there, but obviously these are technologies, and it's very much this kind of ramp-up curve at the moment. We're fortunate in this region that we've seen early rollout by the network operators in this particular region, so it actually gives you a great test bed to actually start playing around with some of these new connectivity technologies and sort of experiencing exactly what they can offer. This is kind of where they fit into the sort of map, if you like, in terms of different types of technology, connectivity technologies. They kind of sit under the traditional mobile technologies, and so far that we're trying to lower the power consumption of the device and the radio module itself, offer extended range. That can equate into better in-building penetration, so actually getting signals further into buildings, potentially even into basements underground in some cases. And that obviously extends the mobile network reach quite considerably. And that's a great benefit here as well. So you can see from this, the area, the gap these type of technologies are trying to specifically address. Question of 5G. 5G often gets raised. Well, how does 5G relate to these two classes of technology? Well, 5G is a term that relates to the standardization process that takes place inside an organization called 3GPP. 3GPP every 18 months releases a new version of its standard. And LTE and narrowband IoT first appeared in the release 13 standard, and will be continued forward from that point. So they naturally integrate and become part naturally of the 5G specifications. So whilst 5G brings some additional capabilities and the core network evolves, introduces some new radio connectivity, LTM and narrowband IoT are carried forward into the 5G specification. I raise this point because obviously the point I had in one of the previous slides is that IoT applications tend to have to exist for many, many years. You deploy a technology into infrastructure, into roads, into buildings. It needs to be there for a very long time. By having this sort of natural evolution of the technologies into 5G and beyond, it gives that confidence that these technologies are going to be here for a very, very long period of time. So while making investment choices, you can be pretty certain that these sort of forms of connectivity are going to be there in 10, 20 years' time. The other key attribute that these technologies bring is global scale. They're being deployed in all regions. You can see the map here. I think this was updated in October. So 123 commercial launches as yet. And obviously this is still very much in the ramp-up stage. We will see the whole globe support these technologies in the not too distant future. And in most regions, it means the deployment of both technologies. They're not competitor technologies. They do have different properties to them. LTM is a slightly larger bandwidth capability over narrowband IoT. There's some differences in the radio propagation and so forth. So what we're seeing is that both technologies are rolling out both territories. So you can see here in the US, the operators have launched both LTM and narrowband IoT across this nation. And obviously we at the GSMA very much want to drive this picture, because what this brings, this global connectivity, is global scale. And that pushes down cost and also gives the confidence to the market to adopt these technologies, because you can build once and deploy anywhere. So that's a good news story in terms of where we are in terms of network rollout, and that figure will ramp up over the next few months and years. Obviously, all this information in terms of network rollout is something we maintain on our website. So if you ever want to see what the latest status is in your region or globally, you can go and get that information from our website. The other point to note on that slide is that we're now seeing roaming between those different network operators of these technologies. And obviously, that's absolutely key for global rollout. Another thing we do as a trade body is we try and build ecosystems. around LTE-M and NB-IoT. It's all very well to have a standard, but we need networks to be deployed, we need modules to become available, we need a whole ecosystem to really build around these two technologies. And we do what we can to promote the ecosystem. We have an innovators forum, 1,500 companies currently registered, and we'd urge anyone who's involved in these technologies, join our innovators ecosystem, get some free promotion. We'll promote you as best we can to the wider industry, events like this, plus our own events that we run around the world. You can see some sort of typical information that we have on the website. So if you do register, become a mobile innovator, you'll get your own place on our website and get to post a little bit of information about your company and where you fit into the ecosystem, sort of explain some of the services that you can provide. And obviously this then becomes something that's easily accessible to anybody searching for these type of companies. Another thing we run is workshops. So I'm here at an ARM workshop, which is great. But we also run developer workshops of our own. Next one actually taking place at a small event called CES. So it's co-located on January the 8th. Obviously ARM, Arduino, going to be there running some workshops, plus some other partners as well, like Telit and Curiosity, and some other partners have yet to sell on the dotted line, but will be announced very, very soon. So if you're CES, you want to come along and do some more developer type activities, please come along to our workshop. You can register on the link there. If you've got colleagues coming, please let them know about that one. Okay, let me take a little sip of water and then we can talk a little bit about security, sort of building upon the last speaker. So this is more comfortable territory for me because my particular focus at GSMA is on the security project. Worked on sort of security-related aspects for probably about 9-10 years now. My original project when I joined the GSMA was the embedded SIM that you've just heard about. But more recently, focusing on IoT security as sort of a horizontal enabler. Why is the GSMA working on IoT security? Well, a lot of what the GSMA does is about promoting the mobile industry and has a very specific bias towards cellular. But in terms of the security work, it's all about overcoming a market barrier. Now, what can we do as an industry association to perhaps help make sure that the IoT is more secure than it perhaps currently is? How do we make services successful and how do we make sure data is protected? And so we started working on this about 3 years ago and produced our first set of guidelines, I think well over two and a half years ago. And the reason that we did that is we knew there was going to be, obviously pressure for services to be secure, but also potentially, regulatory pressure building. And that's obviously what we've seen come to fruition recently. All across the world, various standards bodies, governments, regulators now publishing early drafts of the policy or regulation and laws to make sure that IoT services coming to market are safe and secure. And obviously, particularly in this region, Bill 327 coming into law January the 1st, probably the pioneering first piece of policy that we're seeing coming to fruition in the world. This region is obviously well ahead of the game from a regulatory point of view. But what's typically missing from most of these documents you see published by these various bodies is that what's lacking here is really any detail. Look at the California bill, you look at, come from the UK, if you look at the UK government code of practice, tend to be sort of a bullet point list of some security properties, and it basically says you must be secure by design. It doesn't really give much of a hint as to actually what you need to do as a business to be compliant to these new laws that are coming. And really that's where some of the work that GSMA has done comes into play. Actually, you'll see our work referenced by certainly not the California bill, but all those other documents, policy documents there referencing our work and our security guidelines. Let's talk about what those guidelines contain. Well, what the GSMA security guidelines contain is a basically a how-to guide. It's how to secure, by secure I mean make sure that services are available, make sure that identities are protected, and to ensure privacy and integrity. But how to do that specifically in a sort of IoT world. So how do you do that with low-power devices, low-cost devices, devices that are going to be out there for 10, 15 years, devices that are physically accessible. So all sorts of challenges that are not necessarily relevant to the laptop world, the PC world, the smartphone world, where we protect our devices with our lives. You know, the poor old IoT device is going to be out there. It's going to be subject to all sorts of threats that are kind of new to this particular environment. So those are the specific areas that we want to develop guidelines to address. Didn't want to kind of reinvent the wheel here, focusing on what's really, really important. And that's what we have with our IoT security guidelines. And these are all freely available resources that you can go and download from our website. There's a hierarchy to the document set. So we've got this high-level document at the top here, the security principles document, talks about security from a high level. It's actually intended to be a document that could be read by anybody, not a security expert. Just somebody who wants to get a kind of grip on what IoT security is all about, what it means to my organization. You know, it sort of debunks some of the terms. You know, what does security by design mean? What does privacy by design mean? What does end-to-end security mean, etc. Hopefully, once you've read that, you could be convinced you need to take it seriously, and you probably need to employ a security expert. And it's those security experts that probably then need to read this kind of middle level of documents that really focus on the components that build an IoT service. This is really where the detail is, this middle layer. We have guidelines for what we call the service ecosystems, that's the cloud, guidelines for the endpoints, and that's probably the largest document in the set. How do you secure your endpoint devices? And then another document focused at the network side. And then underpinning all of that, it's great to have guidelines, and we're not the only show in town. You can go out and get guidelines from all sorts of organizations. What's really key is actually proving, what you've done. If you want to say that you're compliant to a particular policy, regulatory policy, you probably need to prove you're compliant to a set of industry security guidelines. How do you prove you're compliant? Well, you need to do a security assessment, and that's what we've got this document at the bottom. That's probably the key one if you're a developer. Have a look at the security assessment. It's basically a huge long list of questions that you need to ask yourself, ideally before you develop your product, because you can build the recommendations and the requirements from those. But certainly you need to do it after you've developed the product and before it goes to market. And that way you can go through and check your product actually hit the security target that you set. It's a target you set based upon the risk assessment that you've undertaken on your particular product. The other advantage of the security assessment and that checklist is that it's great for you as perhaps a developer, but also if you're not a developer, you're a buyer, you're looking to buy a particular service, you can push that down the supply chain and say, yeah, I'd like to buy that product off you, prove it's secure. Have you done the assessment? Can you show me the results? You don't need to be a security expert to ask the right questions. And obviously, it being an industry scheme, it's not just a scheme coming from one particular party that may be sort of partisan. It's coming from a wide ecosystem of companies. So you can have some better trust in it that it's going to be a more rounded set of questions that you're asking. The security assessment at the moment is a self-assessment. So we give it as a tool that you use and adapt to your best abilities. There obviously is a move in some parts of the industry to move towards certification. And that's a big step. And that's something that we as an organization, we're feeding a lot of this information into those organizations looking to develop certification models. I think IoT certification almost going to need to develop a new type of certification for the industry. It's a big challenge that's setting itself. So whilst I'd love there to be security certification out there, formal certification through accredited labs, it's going to take time for those schemes to become really good. There's just some figures, facts and figures on terms of the documentation set. It's pretty comprehensive, as you can see from the figures there. We've got lots of other bodies supporting us as well, and that's pretty key because we don't want hundreds of different IoT security guidelines out there in in the industry. This gets confusing. If we can get the industry to sort of gravitate towards particular guidelines, just a few particular guidelines, it does help. So we've tried our best to work with partners, partner organizations to do that. Okay, so let's get a bit more specific. This is kind of the architecture model we have in our guidelines, just showing a basic IoT service architecture with the different components involved. If I pick on one recommendation in the security guidelines, let's going to drill down into what that is. I guess I'll just take another sip of water. It's about 10:30 p.m. for me, so I wouldn't usually be drinking water at that time, of course. So, number one recommendation in the security guidelines, looking at the architecture, it's about the endpoint. Securing the endpoint is the biggest challenge here. All the other components, the networks, the service platforms, they're kind of a little bit of history there. There's a lot of existing security capabilities there that we can largely reuse. It's the endpoint devices that tend to be really vulnerable in an IoT system. And to protect them, the number one recommendation is to implement what we've got a trusted computing base on the device. So what does that mean? I think you know where this is going with this symbol, hopefully. It's all about the root of trust. It seems to be the term the industry is now sort of adopted as this kind of buzzword for the trusted computing base. It's basically the one thing you trust in your endpoint device. What do you actually trust about your endpoint devices? It's got to be the trusted computing base. What is a trusted computing base? Well, in our view, it needs to be probably something built in hardware. May create some debate in the room here. Others may say, no, you can have software-based solutions. Our quite firm view is it needs to be a piece of hardware. And inside that secure hardware, you can secure the identity of the device. You can secure some key cryptographic functions. You can secure your credentials that drive those particular functions. Once you have that, you can do some pretty good stuff. Some pretty key cryptographic operations. You can do mutual authentication, which is pretty key. You can provision and personalize the device securely. This is essential. And you can do some other tasks. There are other things that you can do once you have that base. You can validate software images and so forth. There are other things you can do on top of that. And unsurprisingly, putting the cellular blinkers on again. A common example of a trusted computing base everyone's pretty familiar with is the SIM in its many different form factors now. Obviously evolving to iSIM or integrated UICC going forward as well. And the key thing obviously about the SIM is that it's a fairly simple piece of hardware. It's small, something you can actually prove the security of. And when you're thinking about doing a security certification, that's pretty key because it keeps the cost down. And if you're using the same secure root of trust across many, many products, obviously you have economies of scale and it really drives down the cost. So adopting the SIM into an IoT security model does have great benefits in terms of the overall cost of the solution. And that's what we've really focused on more recently. We spent a couple of years doing proof of concept around using the SIM as a root of trust for IoT. But now we've actually developed a specific service around the SIM. This got named last week, so that's what the previous speaker was talking about. I think previously we had the working title, Common Implementation Guide for Using the SIM as a Root of Trust for IoT Security. It's a nice catchy title, yeah? So we've shortened that, it's IOT Safe. Okay, SIM applet for secure end-to-end communication. It's launching this week. In fact, it should have launched last week, but it's launching this week, Thursday, hopefully. And it basically defines a common way to use the SIM. So if you looked at the solutions in the market today, talked to various carriers about their SIM or root of trust, it tends to be dependent on which suppliers they're using, which SIM suppliers, and the solution will differ from one to the other. In particular, the APIs will differ. So with this initiative inside GSMA, we've actually defined some common APIs. So your application in your device, it doesn't care what type of SIM has been inserted from which particular carrier. it can access the SIM applet, the IoT CM applet in a common way across different operators, different regions. Documents, the document reference numbers there, IoT 4 and IoT 5, will be published on Thursday. You can go away and download those to your heart's content later this week. So what is it? Just to give a little bit of a walkthrough. So let's take a scenario here. We've got a cellular connected IoT device. Video camera's got a SIM in it. Needs to connect over a cellular network. Needs to send its data to the server. And needs to do that securely. So that's what you typically have in a SIM today. If you open up the SIM and have a look inside, find a little operating system, some memories, some security domains, filing system, and so forth. And in there's a network access application. And it's that little application that enables the connectivity to the cellular network. So it does that mutual authentication to the cellular network. It also enables the data to be ciphered between the device and the cellular network. The problem is there's a little bit of a gap there. So yes, your data is secure to the cellular network, but it needs to get to its home server. And that's typically over, obviously, an internet connection. How do you secure that internet connection, that end-to-end connection? Well, you could talk to your network provider, and they could put a VPN between their core network and your server. It's one solution. But it still then involves a hop between the two. And that may be concerning to you, particularly if your device is roaming around the world. You may be a little bit concerned about having a little hop in the pipe there and revealing your data to your cellular network operators, as much as you may trust them. And they're very trustworthy organizations, of course. What you perhaps really want to do is just adopt the kind of internet model today, where you have an end-to-end mutual authentication between the device and the server. And that's where this additional applet, so SIM Safe is effectively an applet that sits in the SIM. So it's sort of crypto safe, effectively. So you can put some additional credentials into that crypto safe, and you can use those credentials to establish your end-to-end, secure end-to-end connectivity using TLS, DTLS, asymmetric crypto, symmetric crypto, whichever you prefer. And that's the value that this application adds. So there's a picture that we saw previously in the ARM presentation. ARM very nicely just talked about the other attribute that's really important here, and that's the fact that you can remotely provision this applet. And anyone who's taken a cellular or an IoT service to market probably realizes that provisioning those IoT devices is one of the biggest headaches. Actually getting secure credentials into those devices, getting them injected securely in a factory that's not under your control. If you could actually do that in field, securely, to a SIM that you trust, actually takes a lot of the headaches away from that whole supply chain issue. And that's what we bring here. So the SIM OTA interface, which actually is the interface that already exists. There's nothing new there. It's again something else that we can leverage in this solution. So the color coding here is just shows some of the existing interfaces in green. The red interfaces here are the interfaces that we've specified in our document set. So there's an interface, common API to be implemented in the device, and then that could be exposed to the client application in the device using an API like PSA or some other friendly API inside the device. And also we have this other interface on the back end, and that's a way for the actual service platform to provision those credentials through the operator OTA channel. And it's obviously pretty helpful if that's done in the same way. And there's just a little bit more about the spec of the application itself. It's actually two applets that we've specified. We called applet 1 the fat app and applet 2 the thin app. We didn't think that was very politically correct, so we call it applet 1 and applet 2. Applet 1 is basically an applet that can support asymmetric crypto. Applet 2 is symmetric crypto. The reason for having two is that if you want to go really light, applet 1 here, we're talking about 20 to 30 kilobytes. If we want to get under 20, perhaps more towards the 10 kilobyte range, and applet 2 is certainly capable of doing that. So it gives them a little bit of flexibility depending on the capabilities of the SIM that you're looking to provision. So we probably need to wrap it up now. So thank you very much for your attention. Appreciate it.